Hello, welcome to my channel once again. In this tutorial, we want to find the equation of a quadratic curve from its graph. In my last videos on finding the equation from the curve, I've shown you how to find the equation in vertex form and how to find the equation in factored form. Today, we're going to find the equation in standard form. When you take a look at this curve, it is not that easy to determine the zeros of this curve because of where they are placed, and the vertex also might not be easily found except we make approximations. Therefore, to find it in standard form, we're going to select 3 convenient points. But before we do that, recall that the standard form of quadratic functions is y equals to ax squared plus bx plus c, where a, b, and c are constants. And the more reason why we have to select 3 convenient points is to get the values of the constant a, b, and c. From this curve, we have several points which are convenient. Here is 1, that is 3, 1. Here is another one, that is 2, negative 1. We have 1 here which is 1, negative 1, and there is 1 here as well which is 0, 1. We'll be making use of this, and this. So we plug in each point into the equation, the standard form, in order to get the corresponding equations that we solve to get the values of a, b, and c. Starting with the first point, which is 0, 1. And it's always good to make choice of 0 because it makes the work easier, as you will see now. So when we plug in 0 for x and 1 for y, we have 1 to be equal to a times 0 squared plus b times 0 plus c. This shows that c is equal to 1, completely eliminating a and b from this point. So we have the value of c, and that makes our work a lot easier. The next point we'll be considering is 1 for x and negative 1 for y. Plugging this in, we have negative 1 to be equal to a times 1 squared plus b times 1 plus c, and c is 1 already gotten. So that we have negative 1 to be equal to a plus b plus 1, where we subtract 1 from both sides to give us negative 1 minus 1 equals to a plus b, and that is a plus b equals to negative 2. We're going to call this equation 1, while we consider the third point, which is 3, 1. At 3, 1, we have 1 for y equals to a times 3 squared plus b times 3 plus c, which is 1. Then subtracting 1, we have 1 minus 1 on the left. 9a as 3 squared is 9, then plus 3b, which means that the equation is 9a plus 3b equals to 0. We divide through by 3. And dividing through by 3 is going to give us 3a plus b equals to 0 as equation 2. We then solve the simultaneous equations that we have by subtracting equation 1 from 2. This equation 2, which is 3a plus b equals to 0, minus equation 1, which is A plus B equals to negative 2. This is going to give us 2A equals to 2, and dividing both sides by 2, A is 1. So the value of A is plugged into any of the two equations to get the corresponding value of B. And we'll be using equation 2. There, equation 2 is 3A plus B. That's 3 times 1 plus B equals to 0. B is going to be negative 3. Now that we have the values of A, which is 1, B, which is negative 3, and C, which is 1, we substitute back into the standard form of quadratic functions to have the required function. Thus, the required function for the quadratic curve is y equals to ax, which is 1, ax squared, which is 1 times x squared, plus bx, which is negative 3 times x, plus c. That simplified, the function is x squared minus 3x plus 1. This is the function whose curve is given. I believe you enjoyed today's tutorial. Before you go, I've got this for you. Find the equation of this quadratic curve. Let me know your answer in the comment section. Don't forget to like and share the video. Perhaps you're yet to subscribe to my channel. Now is the perfect time to do so. And click on the notification bell as well so that you get updates from time to time from my channel. Thank you for watching this video, and I believe you're going to watch the next one. Thank you and bye.